Welcome to the 12th and one of the last lab sessions of our circuit programming in C laboratory series of the computer networks course. So today we will be covering one of the last topics, which is domain name system. All right, before going into technical details, let's try to understand what that domain name system is. As I told, the DNS stands for domain name system. It is basically a system that covers the IP address, difficulty of representing the IP address to humans. Basically, it is used to cover the numbers with a text so that people can read it easily. To connect to a server for a socket, you have to know the IP address. We need its machine-readable numerical address, which is the server's IP address. And humans are not good at memorizing numbers, right? That's why we had to come up with something that would convert that number into a text and do the opposite as well. And DNS allows us to use human-readable domain name instead of a numerical IP address. So basically, we wouldn't have to memorize this number if we try to open the naver.com's website. 210, 89, 164, 90. We don't have to memorize it, but what we have to memorize is naver.com. And there is a tons of stuff that's happening when we open our browser and type in this naver.com and just click enter. So what's happening is our computer trying to figure out the IP address of naver.com's server using DNS. So client requests IP address for the given host name, domain name in our case it's naver.com, from a DNS server, which is obliged to provide IP address for domain names if available. Alright, so now that we know what DNS is and what it stands for, I believe you have already covered in the lectures, but again I'll have to explain it one more time to give you a rough overview how that DNS works. DNS is like if you try to imagine it, it's like a distributed system of computers hierarchically placed to talk to each other in order to finish a client's task. Like this on the left side, the image, you can see how the servers, how the domain name servers, domain name system servers are placed as a distributed system in a hierarchical order, like Wikipedia or .org being a part of the org domain name system, and that being part of the root. So that root is the biggest DNS server available that connects the second level domain name servers. It can be like the second level can be the .org.com, .net, .co, I don't know, .brew or .whatever. So there are a lot of second layer domain name services. And when you open a website inside your computer, inside your laptop, what's happening is your laptop is trying to figure out the IP address by asking that what is the IP address for naver.com from the default DNS server inside your local network. And if that local network doesn't know the IP address of that domain name that you have provided, what it will do is it will transfer the request to the domain name server that it's connected to. It can be the third layer or fourth layer DNS server, it can be the second one or whatever. So it will basically transfer it, and that DNS server will also transfer it to the root DNS server. So that's how your request reaches the root. And from that root, as it has an access to the second layer DNS servers, it will transfer it accordingly. Like if you try to figure out what is the IP address of youtube.com, it will transfer it to the .com domain name server. And that domain name server will also redirect to the appropriate server, which will be the youtube.com DNS server, the youtube.com network. And inside the network, they have their own default DNS server that will either respond to your request like just immediately, or it will also try to figure out what machine responds to that domain name. Um, and then your computer will receive in the same path, it will receive back the DNS response, and that DNS response will contain the IP address of the domain name that you have provided. And in our case, it was youtube.com, right? So that's how you will know the IP address of youtube.com. This could be like just tested by opening up the terminal and trying to ping the IP address that stands for youtube.com, right? Let's try to figure out the IP address of youtube.com. If you do ping, then you will see the IP address. So here what's happening is your computer sending the DNS query and the same thing that I've just explained being processed and result coming back. All right, let's go into the details of how that works inside our socket programming in C. Acquiring IP address using a domain name in socket programming. So one function that we have to know is called GetHostByName, and that accepts the domain name, that host name that we want to figure out which IP address stands for the, I just confused you. That hostname accepts one parameter um, of which we are trying to figure out the equivalent IP address. So basically we're providing youtube.com as an argument to get host by name. And as a result, we're getting some structure that contains the IP address um, as its content. And the GetHostByName function returns a structure of type getHost for the given host name. And that structure contains these 5 fields, which I will explain in the next slide in details. The first one is the official name. The second is alias list, host address type, address length, and address list. And I want to point out one more time, we're trying to figure out the IP address for youtube.com, right? And if you provide an IP address instead of a youtube.com, then the result will be just that IP address that you have just provided, right? Because it doesn't have to try to figure out the IP address of an IP address, right? It has to figure out the IP address of the domain name. So if the value that you have provided as a name is an IP address of version 4 or 6, there will be no lookup. There will be no DNS lookup. And simply what the program will do is it will copy the value that you've provided, the IP address, into the HNAME field, and it will just return that result. That's it. Let's try to understand what are the fields. Now, HNAME is the official name of the host. So if you're trying to figure out the IP address of youtube.com, it could have some different the different domain name that is that can represent that server better. If you're trying to do the same thing with naver.com, it could also have some different URL that is more hierarchically important than naver.com, and that will be placed right here. And the alias will be all equivalent domain names that can give the result exactly the same way as the official name. And we will be seeing the examples. The aliases can be multiple. The multiple domain names can be matching with the same IP address. And that will be the second field right here. And it will be a list of the domain names as aliases, terminated by a null pointer. And then the address type is can have two types of values, which are AFINet or AFINet6 at present. Just there are two address types, IPv4 and IPv6. And the next property, the next element is the length, which is the length in bytes of the address of the IP addresses that we're getting. And the H address list is the target values of interest that we're trying to figure out because we are trying to figure out the IP address of youtube.com or naver.com, right? Those addresses will be stored inside here. And it can be a list of IP addresses because there can be multiple machines that correspond to the same host name, right? And that array points to the network addresses for hosts in network byte order. I want to highlight in network byte order, it's not human readable, so we have to convert it back to human readable separated by dots, right? And that will be a list of IP addresses terminated by null pointer as well. And if we try to take a look at how technically it looks, first we will make a function call to GetHostByName, providing the youtube.com or naver.com or that text, the domain name as a parameter, and then we will be storing back the result inside the pointer to the host entry structure. And then if it's null, then there will be an error. It's just error checking. And then otherwise, if it's not error, we are printing out the properties, which were first official name of that domain name and the aliases, all possible alternative domain names to the official name. And then the address type, which can be just AFINet or AFINet6, just IPv4 or IPv6, right? The next thing is the goal or goal, the IP addresses. It can be also multiple. So we are looping until we reach to the null pointer, which will give us the false result, and then it will just stop that for loop. We are printing out each element of this H address list one by one by converting them back from the network ordered by the network ordered address to human readable dot separated notation, and printing out them with this little line of code. So the result is, after understanding this, the result is we compile it, the source file, and run it as here. For example, here we're trying to figure out the IP address of 3wnaver.com, and the official name, it differs a little bit. So in that server, the set of servers inside the Naver Corporation, the 3wgnaver.com is accepted as the official one, so that's how they set it. And then the alias is the one that we've just entered here. So they're equivalently powerful, equivalently accessible by clients. And I want to make one more note that this can be different already because it's not constant. We have such thing as DNS, and when we try to compile and run with the exact same values like hostname 3wnaver.com, we might not have the same results because maybe naver.com has already changed the official name to a different value. So we'll just compile and run and see if it's still matching. And the next thing is the addresses that we're getting are IPv4. And they have two exactly matching IP addresses, which are 202.131.21 blah blah blah. The second one is this, and both of them stand for the naver.com server. Let's try to compile and run ourselves. And before that, let us open up the source file, which is GetHostByName.c, and see if it's matching with the slides, with the coding slides. So the first thing we're doing is we're creating the variable, and oh, by the way, don't forget this netdb.h file, that is for the DNS. And the first thing we're doing is we're creating a pointer to the host entry structures object, and it's just for results. And we're getting the domain name as a parameter right here. We're just checking if it's matching. Like the number of parameters is 2, which is first is the program's name, and second is the domain name. And then we are making a function call to GetHostByName by providing that youtube.com or naver.com as a parameter, and we're getting the result. We're checking if there's been an error. Otherwise, we are printing out the official name that represents that host name. And then the aliases, all possible aliases, alternative namings, and the address type, which will be IPv4 or IPv6, after which we are printing out exactly the same way as in the slides. We are printing out each IP address by converting them back to the human readable dot separated notation of IPv4. And that we're getting from the hosts haddr_list field by providing the index, right? So this is just one network ordered address that should be converted back to a pointer and then accessed by an address and converted back to a dotted notation string. That will be printed out by this little flag on this line of code. Alright, so now that we know how this DNS is being written in a code, let's try to compile and see it in practice. In this case, what we'll be doing is we'll be just repeating the same thing they've done inside this compiling and running. If we'll check if it's the same, still the same. And I think it's not the same because they tend to change it all the time. Okay, let's compile it. gcc-o get host by name. Oops, I think I'll have to change my folder. Yes. Okay, gcc-o get host by name GetHostByName.c file. So now that we have compiled it, let's try to run it. GetHostByName 3w naver.com. And now we can see that the official name has changed. It's not g.naver.com already. They've already changed it to a different official name. And the alias is the one that we've provided. And then the address type is the IPv4, and the IP addresses that we have been trying to find are as following. And if we try to open them, oops, then we will be directed to the naver.com because that's the website's name, right? The official name also stands for naver.com. The IP addresses that we have received as a result, they also stand for the naver.com. And also the second one is the same, stands for the naver.com. So that's basically the name of the domain name, human readable domain name of these IP addresses, which are these two. And now that we know how we can get the IP address of the URLs, the domain names, we can just check one more thing, like the localhost, just so that we can have variety. Okay, localhost. Now the localhost represents this IP address, and that is actually defined inside your computer. If you try to open this etc hosts, you will see that localhost keyword is mapped to this your address, and how your machine is getting the this result when you run your program is just reading from etc host because it's already there. Now that we know how it works, we can move on to the next one, which is a little bit interesting and tricky, which is doing the opposite of GetHostByName. It is getting host name from the address. It's basically not trying to figure out what is the IP address of naver.com, but it's trying to figure out the naver.com from the IP address. So that's how we can understand. And GuestHostByAddress accepts these three parameters, and resulting value is returned as a returning value. And the first is the address, which is the IP address that we want to try to figure out what is the domain name, and we have to specify the size in bytes and the address family. We can see it in practice right away and then just understand it. Okay, so first we are clearing out the memory area to which we want to load the IP address, and that IP address will be assigned to the saddr field of the sockaddr in data structure. By this time you should already know it because we have been covering it all the time. It's just specifying the IP address. And after we specify the IP address, we are passing that value, that as a value to the GetHostByAddr function, and saying it's just 4 bytes, and the address family is AFINet, which is IPv4, and getting the result, which should contain the official name and aliases. And when we do it, there could be some error. We're just checking it and then printing out exactly the same way as in the previous example. It's just the same data structure, the host end data structure, and printing out the official name, aliases, the IP address, and stuff. If we try to figure out the domain name of this IP, for instance, it will give us the official name of the server that responds to this IP address, that has this IP address. And we will see the AFINet, which will be the IPv4, and the value of the IPv4 that we've just provided right here. Let's try to see the code and confirm that it's matching first. So we again have this header file, and then we're creating the two variables. This one is for the result, then this one is for parameter. This is the IPv4 parameter that we'll be providing to the GetHostByAddress later on, and that we're zeroing out before providing the IP address that we get from the console as an argument. We are setting it to this field of this header, which I've created right here. And then we're making a function call to the GetHostByAddress. It's not by name. I want to highlight one more time. If it was GetHostByName, you would be trying to figure out the IP address of a domain name. And now we are trying to figure out the domain name of an IP address. So if you call GetHostByAddress and provide the IP address and specify the size and family, you will get the result as the host entry pointer. And then you have to check the error and print out exactly the same way as we did in the previous example. We are printing out the official name, aliases, address type, and IP addresses. Okay, so now that we know how the code is written, let's try to compile and see how it works. gcc-o get host by, in this case it will be address, and get host by address.c. Let's try to run it. The first thing that I want to check is 127.0.0.1, which is the local host. I want to see the local host being printed out right here. If it does, then the reverse of the DNS works, right? That's what we're trying to get. So now we can see that the official name is localhost, which was our goal. We are getting the domain name of this IP address, which is right here, and it has an alias, this one, and the address is of type IPv4, and this is the value that we've just provided right here. Let's try to run this IP address, and see if it still belongs to Google. It's just like one interesting curiosity. Like, it's just one curiosity, right? Does this IP address belong to Google, right? It could be your question. 74.125.19106. 19106. If we try to run it, it will say no, because it's not the Google's IP address anymore. All right. What is Google's IP address? Let's try to ping and see. Okay, so this is Google's. Let's try to do this one. Get host by address and provide that one. And now we can see that this official name represents this address, right? And if we open, if we open our little browser, and put this address, we can see that this domain name actually belongs to Google, right? And that means it's valid. The get host by address had found the machine the domain name that represents this IP address. So that was our goal, and that finishes our 12th session. That was quite short, I know. The next laboratory session will be the overview of what we have covered by far, starting from the introduction, the steps of TCP connection establishment, the types of the protocols like TCP UDP, and how the packets are transferred, how we can transfer files, how to do multiple process clients and TCP servers, how to do multi-threading, and so on and so forth. The next laboratory session will be the overall review of what we have covered. And thank you for paying attention. I hope to see you in the next lab session. Bye.